Hi friends, hope you all are doing good. Okay, so yesterday we discussed ionic product of water. So which was like at 298 kelvins, which is 25 degrees Celsius. Kw of water is equal to 10 to the power negative 14. Correct? And the concentration of H positive and OH negative equal to OH negative for the neutral solution is 10 to the power negative 7 mole decimeter per decimeter cube. Okay, so basically in the solution, the molar concentration of H positive is very small. Like it is, you can see here also, it is 10 to the power negative 7, which is really a small number. So basically what we do to represent the H positive concentration, we use the term pH. So what is pH? pH is negative logarithm of hydronium ion concentration of hydronium ion. So the concentration should be in, remember this is really important, the concentration should be in mole per decimeter cube. So pH equals to negative log concentration of H positive or hydronium ion, anything. So for the acidic solution, pH is less than 7. For the basic solution to be basic in nature, pH would be more than 7. And for the neutral solution, pH is equal to 7. Okay, I hope this is clear. So just remember pH is equal to, so this formula. And remember that concentration should be in mole per decimeter cube. And mole per decimeter cube is molar, like molarity. Basically, you have to consider the molarity. Okay, so here we have a question. Calculate pH of a solution of a soft drink whose hydronium ion concentration is 3.8 into 10 to the power negative 3 mole per decimeter cube. So we have to calculate the pH. So we know that pH equals to negative log of H positive. Here the concentration of H positive is given as 3.8 into 10 to the power negative 3. So let us put it. So negative log 3.8 into 10 to the power negative 3. So answer is the pH would be, calculate this value, and answer is 2.42. Remember one thing. So this is log base 10. Log base 10. Okay. So log base 10 hydronium ion concentration. Fine. I hope this is clear. Okay. Now what we will do next, we will discuss few previous year questions, few sample question paper, and few sample questions, and basically do try them with me. And okay, let's get started. Okay. So let us do the first question. Just 1 second. Give me 1 second. Okay. The first question says, ionic product of water is water at 30 degrees Celsius is 1.47 into 10 to the power negative 4 mole square decimeter 6. Calculate the pH of water at this temperature. So basically, we have to calculate the pH of water at this particular temperature. Okay, so this is a very easy question. Just stay with me, stay focused. Drink a glass of water if you are feeling sleepy. let's get started. So we know the formula of pH. What is pH? pH is negative log H positive concentration, correct? And what is the formula? So let me name it as 1. So next we have Kw. Kw is equal to, so what value they have given? The ionic product of water is this much. So they have given the value. Kw equals to 1.47 into 10 to the power negative 14. So what is the expression of Kw? If you don't know the expression of Kw, refer to the previous video. I will pin that video in the comment. Do watch it. It is very interesting video and it has so many questions related to Kw. So Kw equals to H positive concentration and OH negative concentration. Correct? So let us put this value. Just remember one thing, as we discussed earlier, for the neutral solution, H positive concentration is equal to OH negative concentration. So name it as 2. So Kw equal to, so what I will do, I will replace the OH with H positive. So H positive concentration into H positive concentration. So Kw is 1.47 into 10 to the power negative 14 equals to square, correct? So H positive concentration equals to root 1.47 into 10 to the power negative 14. So solve it, you will get H positive concentration to be 1.2124 mole per decimeter cube. Fine, now we have H positive concentration. Now what we have to do, we have to find the pH. How we will calculate that? So using the equation 1. So we have the concentration of H positive, we will put it. So pH equals to negative log concentration of H positive, which is 1.2124. And after solving it, just take the log of this and you will get 6.1. Yeah, 6. So this is your answer. Don't round off it to 6.92. Okay, don't do that. Just keep it as it is. So just go through this question. We did nothing. We just used the expression of Kw and we just used the two formulas, pH and Kw expression, and we got these values and we can calculate the pH. Okay, fine. I hope this is clear. Let's move to the second question now. Okay. So previous question was of 3 marks. Okay, so this question, what it says, it is of 8 marks. So stay focused. So at 298 Kelvin, 25 centimeter cube. So centimeter cube is what? Milliliters. 1 centimeter cube is equal to 1000. Oh, no. 1 centimeter cube is equal to 1 milliliter. So same thing. Either use centimeter cube or use milliliter. Both are same. Okay. So at 298 Kelvin, 25 centimeter cube of solution of a strong acid contain this much of the hydrogen ion. So we have to calculate the hydrogen ion concentration in this solution and hence the pH. Okay, let us do that. So what is concentration? So what do you mean by concentration? I'll solve it here. Concentration is basically molarity. So they are asking you about the molarity. What is the formula of molarity? Molarity is equal to moles by volume, and volume should be in liters. If the volume is in milliliters, then it would be moles volume times 1000. So we will use this expression because we have volume in milliliters. So let us put the values. How many moles of H positive are there? See here. So you have 1.5 into 10 to the power negative 3 moles of hydrogen ions. So let us put here 1.5 into 10 to the power negative 3. And what is the volume? The volume is 25 ml or 25 centimeter cube times 1000. So this got cancelled and the molarity comes out to be, concentration would be how much? Just calculate it and you will get the value as 0.06 mole per decimeter cube. So the concentration of H positive ion is this much. Fine. Next, you have to calculate the pH. So what is the formula of pH? Again, writing the formula. pH is negative log of H positive ion concentration. So negative log of what is the concentration of H positive? So you have got 0.06. So it would be 0.06. Okay. So do this. Take the negative log and you will get as 1.2 as your answer. I hope this is clear. Okay. Moving to the next question, what they say, calculate the pH of a solution formed after addition of 25 centimeter cube of 0.15 molar NaOH to the original 25 centimeter cube of acid. So this is little lengthy, but really interesting. So stay with me, stay focused, and you will be able to solve this question. Okay, so let us assume this strong acid to be any hypothetical acid, HX. Let me take it as HX. So HX is reacting with NaOH, correct? NaOH. And it will form, what is the reaction between acid and a base? Salt plus water. So it will form salt, which is NaX, plus water, which is H2O. Okay. Now, how much milliliters of water, NaOH we have? So we have 50 milliliters or 50 centimeter cube. 50 centimeter cube of NaOH, which is 0.15 molar. So molar, what is the meaning of molar? Molar means mole per decimeter cube. So same thing, either you use molar or you use mole per decimeter cube. Both are same. Fine. So let us find the moles of NaOH. So the moles, how to calculate the moles now? Same formula, molarity. Molarity is equal to moles by volume. If the volume is in milliliters, multiply by 1000. So molarity we have is 0.15. 0.15 equals to moles. Moles we have to calculate? Volume is 50 times 1000. Okay. So after solving this, use your calculator and solve it. It will come out to be 7.5 into 10 to the power negative 3. So this much moles of NaOH. So moles of NaOH equal to 7.5 into 10 to the power negative 3. Okay. Now see, I'll be doing a very nice thing. So you have 7.5 into 10 to the power negative 3 moles of NaOH. And how many moles of acid you have? So they have given you 1.5 into 10 to the power negative 3 mole of hydrogen ions. Hydrogen ions basically you get from acid. So these are the moles of acid. So moles of acid would be 1.5 into 10 to the negative 3. So we will just assume acid to be monoprotic and basically the moles are this much. Okay. So basically now what will happen? So this much moles of acid we have and this much moles of NaOH we have. So what will happen? Neutralization will happen. So after neutralizing, but the acid is here limiting reagent. Acid is present in lesser amount. So if acid is present in lesser amount, the base would still remain in the beaker. Like let us take, instead of taking this larger numbers, if I say you have 2 moles of acid and 5 moles of NaOH. So what will happen? So 2 moles of acid will react with 2 moles of NaOH, and you will still left with 3 moles of NaOH in the solution. Correct? So same thing. So you have 1.5 into 10 to the power negative 3 moles of acid and 7.5 into 10 to the power negative 3 moles of NaOH. So NaOH is present in more amount, so it will remain still in the solution. So how much excess of NaOH we have? Excess amount of NaOH is equal to 7.5 into 10 to the power negative 3 minus 1.5 into 10 to the power negative 3, which would come out to be 6 into 10 to the power negative 3. So this much moles of NaOH are present in excess. Fine. Okay, now I will be continuing here. Okay. So we have NaOH. So NaOH will dissociate in what? NaOH will dissociate in Na positive plus OH negative. Correct? So if you have 6 into 10 to the power negative 3 moles of NaOH, so how many moles of OH negative you will have? 6 into 10 to the power negative 3 moles of OH. Correct? So now what we have to do? We need concentration. These are moles. We have moles, but what we need concentration. So again, we will use the same formula, molarity. Molarity is equal to moles by volume into 1000. So we need molarity. So molarity will come out to be how many moles? 6 into 10 to the power negative 3 divided by volume. Now, what is the volume? Pause it and guess the volume. Okay, so the volume is basically you have 25 ml of the strong acid and 50 centimeter cube or 50 ml of NaOH. So the total volume would be, what would be you have added NaOH solution to the solution of acid. So what would be the total volume? Total volume would be 75. So 75 into 1000. I hope this is clear. Okay, and just find it. The molarity will come out to be 0.08. Okay, mole per decimeter cube. So now what they are asking? They are asking about pH. But we know that pH is negative log H positive concentration. But we just have what we have. We have the concentration of OH negative. We need H positive concentration. Now, how to do that? So, see the temperature. What temperature we have? The reaction is taking place at 298 Kelvin, which is 25 degrees Celsius. So, you know that Kw at 25 degrees Celsius is 10 to the power negative 14. So, Kw is 10 to the power negative 14. Okay. So, Kw equals to H positive concentration and concentration of OH negative. So 10 to the power negative 14 is equal to H positive concentration. And what is the concentration of OH negative you have? 0.08. So 0.08 divided 0.08 equals to H positive concentration. So what it will come out to be 12.5 into 10 to the power negative 14 is equal to H positive concentration. So I'll tell you a simple trick to divide it. Instead of writing the whole number, just represent this as 1 into 0.08 times 10 to the power negative 14. So just divide 1 by 0.08, you will get your answer. And just write 10 to the power negative 14 as it is. Okay. So fine, you got the concentration of H positive. So now what is the formula of pH? Again, writing it. I hope you guys remember now. pH is equal to log H positive concentration. So pH is equal to negative log. What is the concentration of H positive? Concentration of H positive is 12.5 into 10 to the power negative 14. Solve it and you will get pH as 12.9. Okay. Okay. And one interesting fact, what is the full form of pH? So comment it. Full form of pH. I hope this question is clear. Okay, let's move to the other question now. Fine. Okay, so this question is for you guys. It states that ionic product is this at 313 Kelvin. So you have to calculate the pH of water at this temperature. We did a similar question, and what you need to do, solve this question and send it on our emails. Okay. Now let's move to the next question. So what it states, calculate the concentration in mole per decimeter cube of a solution of hydrochloric acid which has pH of 1.13. So they have given us the pH value, which is 1.13, and we have to calculate the concentration of hydrochloric acid. Okay, hydrochloric acid, or you can simply say you need to calculate the concentration of H positive ions. Why? Because hydrochloric acid is a strong acid, it dissociates completely into H positive ions and Cl negative ions. Okay, so calculating the hydronium ion concentration will give you the concentration of hydrochloric acid. So again, use the formula, pH is equal to negative log of H positive. And what is the pH given here? 1.13. Yeah, 1.13. So 1.13 equals to negative log H positive. Okay. Now how to solve this? So basically one way is taking anti-log on both sides. If you take anti-log on both sides, you will get the answer. Or other way, what you can do. So what is the meaning of anti-log actually? Take this minus to other side. It would be negative 1.13 equal to log H positive. So if you need to calculate this value, simply do 10 to the power negative 1.13 equal to H positive ion concentration. And solve it and you will get the concentration of H positive to be 0.074 mole per decimeter cube. Okay. Either take anti-log on both sides or just do 10 to the power negative 1.13. How to take anti-log? Basically, press shift and log. If you will press shift and log in your calculator, you will get anti-log value. Okay. Next question. Calculate the concentration in mole per decimeter cube of a solution of chloric acid which has a pH of 4.23. Chloric acid is a weak acid with the dissociation constant to be this much. So they have given us the dissociation constant. So first of all, write the equation. So chloric acid, HOCl, weak acid, it is a weak acid, so it will dissociate like this. So it would be H positive plus OCl negative. So what is the formula of how to write Ka? Ka is H positive concentration and OCl negative concentration divided by HOCl concentration. So we have to find the concentration of this. We have to find this value. For this, we need to calculate this and this also. So what is the pH? pH is 4.23. So they have given us the pH. So pH is equal to negative log of H positive concentration. So pH is 4.23 equal to negative log H positive concentration. So we need to find the concentration of H positive first. So taking anti-log on both sides or taking 10 to the power negative 4.23 equals to concentration of H positive. So what would be the concentration of H positive? H positive will come out to be 5.888 into 10 to the power negative 5 mole per decimeter cube. So rounding it off, we will get 5.89 into 10 to the power negative 5 mole per decimeter cube. So you got the concentration of H positive. Now see this equation. H positive and OCl negative are equal, correct? So OCl negative concentration would be 5.89 into 10 to the power negative 5 mole per decimeter cube. So we got this value and this value. Now we have Ka also. So Ka is 3.72 into 10 to the power negative 8 equals to 5.89 into 10 to the power negative 5 times 5.89 into 10 to the power negative 5. Divide by concentration of HOCl. So HOCl would be equal to 5.89 into 10 to the power negative 5 into 5.89 into 10 to the power negative 5 divide by 3.72 into 10 raised to power negative 8. Solve it and you will get the concentration of HOCl to be 0.0932 mole per decimeter cube. Okay. Hope this is clear. This was easy. Okay, now let's move to the next question. Okay, so this is the next question. You have the pH. The pH of this much sulfuric acid is 0.98. Calculate the concentration of hydrogen ion in the solution. So this is for you. Mail this answer at wisdomscience25@gmail.com. One important information, we provide individual tuitions also, like in chemistry. So if you need any, you can mail us and we will do the further conversation. I hope this is clear. If you want more videos related to the questions, just text me or mail me. We will come up with some more previous year question solving videos. I hope everything is clear. You enjoyed it. Okay, then see you. Bye-bye. Do subscribe it and share it.